Common ion effect. The common ion effect describes the decrease in the solubility of a slightly soluble ionic compound or the degree of dissociation of a weak electrolyte when a soluble compounds containing one of the same ion, that is the common ion, is added to the solution. Consider the equilibrium established when a sprangly, that is the slightly soluble salt, such as silver chloride, is dissolved in water. Suppose you add a soluble salt like sodium chloride, which is strong electrolyte and dissociate completely. The addition of sodium chloride significantly increases the concentration of chloride ions in the solution. This is the common ion. See, from dissociation of silver chloride ion, and also from sodium chloride ion. This is the common ion. According to Lechater principle, when the concentration of product is increased, the system must shift to the consume the added product to the restored equilibrium. The equilibrium will shift to left, favoring the formation of the silver chloride. The shift to the left causes more silver ion and chloride ions to precipitate out is the silver chloride, resulting in a lower concentration of silver ions in the solution. This ultimately means the solubility of silver chloride has decreased. Weak electrolytes ionize partially. Each type of weak electrolytes has certain degree of ionization at a particular temperature. For example, ionization of acetic acid in water gives thianoate ion and hydronium ion. For the ionic equilibrium, the ionization constant K equal to equals 3. Okay. In the above equilibrium, if strong electrolyte sodium ethanoate is added, sodium ethanoate dissociates completely, then furnishes the ethanoate ion in sodium ion solution. This increases the concentration of ethanoate ion. To keep the value of K constant, the increase in concentration of ethanoate ion is compensated by the decrease in the concentration of H plus or increase in concentration of ethanoic acid or both. For equilibrium, the ionization of acetic acid is suppressed in presence of acetic ion, which acts as common ion and suppresses the ionization of acetic acid. This effect is called common ion effect. Common ion effect is defined as the suppression of the ionization of weak electrolytes in presence of strong electrolytes having the common ion to that produced by the weak electrolyte. Now let us take another example. Ammonia is weak base and ionizes to a small extent. If strong electrolyte source is ammonium chloride, sodium hydroxide is added, then due to common ion, the degree of ionization in ammonium hydroxide decreases. Application of common ion effect, qualitative salt analysis for the precipitation of group second basic radicals in the form of sulfide. Hydrogen sulfide gas is passed into salt solution in the presence of dilute hydrochloric acid. In the salt analysis, in the presence of dilute hydrochloric acid, the ionization of hydrogen sulfide is suppressed and concentration of sulfide ion is still sufficient to precipitate the group second basic radicals in the form of disulfide, but insufficient to precipitate other basic radicals. Similarly, in the third ion, ammonium chloride solution is added into ammonium hydroxide to suppress the ionization of ammonium hydroxide and concentration of hydroxide ion is controlled.